So after some over 30 minutes preparation, we're finally in a position to create an actual visualization, a plot that looks like a plot. Before we do that, we're just going to run through what we've created already, because there's a lot of stuff in D3, and you have to keep on top of it. The first thing we create are dimensions: width, height, margin, plot height, plot width. We then create a canvas object, and then we create a plot object. So the canvas object, to create that, we use D3 select to identify the canvas ID. We append an SVG object to that. It has the attributes height, width, and background color. We then create a plot object, which is a HTML group object, and we move that across by margin left and down by margin top. Then we create three scales: an X scale, a Y scale, and a color scale. Now, with all those three created, we're now going to create the actual visualization. So, actually, before we do that, we'll just take a peek to make sure it's working. You can never check if it's working too often. See, and you get errors like that for some reason. Let me just check. Okay, because I had the Python server running in the terminal. Earlier, I turned that off. Run Python HTTP server again. Launch the Fox, and here's what we expect. There is our canvas. We look at inspect. Right click down to the bottom. Inspect. Blow that up a little. And here we see our SVG object. Just as soon as I scroll down, we'll see it, I hope. There we go. So here's our SVG object with the attributes we expect: height, width, and then we have the G object that you can't see, because a G object is kind of it's more a theoretical thing than something that exists in material reality. Okay, back to the code. We'll hit Control C to shut down the server, close the terminal, and now we're going to create our visualization. To create a visualization, there are two steps. You have to load the data, and then you have to give the data attributes. To load the data, you write plot dot select all circle. Circle is an SVG concept. It knows what a circle is, it knows how to create it. So it's plot dot select all circle dot data, with data as an argument, dot enter, no argument, and then append circle. If you'd chosen select all rectangle, then you would append rectangle and add attributes appropriate to a rectangle. We're not looking at rectangles here, we're looking at circles. Now, I've read a number of explanations as to how this part loads the data, how the browser understands the data, how this attached to the SVG. I haven't understood any of them, right? All I know is this works. So if it gets a laugh, it stays in the show. Now, having loaded in our data, we need to supply attributes for that data. There are three attributes and a style that we're going to add now. The first attribute we're going to add is center X, which is the X coordinate for the center of a circle. And that would be, we have an accessor function for that. D maps to X scale D dot petal length. Then we have a CY for center Y, and D maps to Y scale, taking the argument D dot petal width. So CX, CY, center X, center Y, and that applies to all circles. As we iterate through the 150 items in the array, these are how each circle is created. Every circle will have a radius of 5, and every circle will be filled according to this accessor function, which is D color scale D dot species, because we're coloring by species. Okay, that is the visualization. Again, it's in two parts. This part loads the data, and then the second part shapes the data. Essentially, it gives it its X and Y center coordinates, its radius, and its color. So we whisper a small prayer. We open up the terminal, and we're gonna run the Python server. And now we launch the Fox, take a look, see if it's working, and it's working. Here are our 150 records found by Dr. Fisher, 1923, of the different irises. We right click one at random to look at it, and here we see for this particular iris, these are the details as broken down, and you know there are 150 items in this group. This group contains 150 nodes. Each node is a circle. The circle has CX, CY, radius, and style attributes, and they're all, you know, different and appropriate to different to the 150 different irises that Professor Fisher recorded. And you can go through them here and see, you know, which one is which. Now, we'll just look at this bottom one here, and you might notice that the CX value for this and the one above it is the same. It's 158 point, big long number. But it's not obvious that there's two irises represented, two or more irises represented by that particular circle. So there's another attribute that we can add back in the code, and that attribute is opacity. We're going to set the opacity to 0.5, and the advantage of opacity with the scatter chart is that if irises are on top, if data are on top of each other, you can tell. So the pale crimson is a single iris, and the darker crimson represents one or more irises. Darker olive represents one or more irises, and the darker dodger blue represents one or more irises. The last thing we're going to do is we're going to get rid of our little hello YouTube joke in the headings, shut down the server and the terminal here, and we're going to change, we're going to give this a proper title, and we're going to do that by calling document dot get element by tag name. Get element by tag name returns an array. So the tag name we're going to look for is H2. It's going to identify all the H2 elements. There's only one H2 element, so that'll be element at index 0. We're going to set the inner HTML of that element to Fisher's iris dataset. And we're going to repeat that, except we're going to get elements by the tag name H3 this time for the subtitle. And this is why I had the H2, H3 elements in there at the time, so that we can customize them in the JavaScript. And we'll just say this is petal length versus petal width. Going to identify these as titles. Check the code. Always check the code. You can't be too paranoid with this stuff. Python-m HTTP server. Launch the Fox. And here's our titles showing up correctly. So we have now learned how to create a visualization, and we can see what that, you know, this is working out now. Well, this is now a recognizable plot. We have only a few things left to go. What the few things are we have to put in axes. We may put in axes labels, we may not, but the main thing we need to add after this is a tooltip, which will allow us to hover over an individual point and find out the details for that point. What the petal width, petal length, sepal, everything we can report about an ISIS, we will report in the tooltip. And that's going to be the fun for, we're going to do axes, then we're going to do the tooltip the next day out. So please like and subscribe to the channel, even if you hate it. I need the encouragement. This isn't easy done. Take it easy, live long and prosper.